everyone, I'm Tasnim Masar and welcome to our Electronic Devices and Circuits class. Generally, solids in terms of their electrical properties can be categorized into three types. One is conductors. These are materials which have free electrons and they can flow in when an electric field is applied, and this causes an electric current. There are insulators where the electrons are tightly bound so they cannot break free and don't conduct electricity. And the third type is semiconductors, which we will be looking into deeper today. Semiconductors are materials which, when heated up, these act like conductors as the electrons break free and are able to move about. Whether they behave as insulators or conductors depends on their composition. So semiconductors can be said to be materials which act both as an insulator and a conductor. So then let's take a deeper look into conductors. On the left hand side, we can see a diagram which shows the conduction band and the valence band of conductors. And we can also see the band gap. In conductors, the valence band is actually empty. The band gap in conductors is so small or non-existent that the conduction is very easy, as the electrons can freely drift between the two bands. So this makes conduction very easy, and the conduction of conductors is actually very high. Next we can see insulators. So in insulators, actually you can see that the valence band is full, and the band gap in insulators is so large that the electrons cannot jump from the valence into the conduction band. So the band gap is large, and this causes the movement of the electrons from the valence band to the conduction band difficult. So hence the conductivity in insulators is very low. And then it comes to we can see the energy band diagram for semiconductors. So in semiconductors, the valence band is full, but the band gap is intermediate, which means that actually in semiconductors the band gap is not so huge as in uh, insulators, but the band gap is exists in an intermediate size. So as we saw that in conductors, the band gap was very small or non-existent, which allowed the electrons to make the movement from valence band to conduction band very easy, and it could do it at any time. But in semiconductors, the band gap, there is an energy level of the band gap which we must overcome to move from the valence band to the conduction band. So the electrons can make the jump from the valence band to the conduction band only when we provide some kind of energy. So this energy can be in the form of heat, and it can also be like we applied an electric field which causes the movement of electrons. So here we can see one example is that intrinsic silicon. So silicon is one semiconductor that we will be studying. So in silicon, in intrinsic silicon, which means that the normal silicon, yeah. So at temperatures above absolute zero, there is a finite probability that an electron will be knocked from its position in the lattice and create a hole. So what happens is the electron was initially here in the lattice, but since we applied an electric field, so if we apply a voltage, so we can say that if a voltage is applied, then the electron and the hole can contribute to a small flow of current. So what this means is that there is a, since the temperature is above zero, above absolute zero, so this means that the electron, there is a probability that the electron will be knocked from its position and create a hole. What does a hole mean? A hole means, a hole is not actually, it's not how we know that electron is a subatomic particle. A hole is like, we can define a hole as being an absence of electron. A hole can also be said an absence of electron. So if a voltage is applied, then the electron and the hole can contribute to a small flow of current. Next we can see, the top is doping. Doping is actually the addition of an impurity, and this can create two types of semiconductors depending on the type of element we add. It can be n-type semiconductor, it can be p-type semiconductor. So in a p-type semiconductor, we add boron or gallium as dopants, and both of these elements have 3 electrons in their outer shells, and upon mixing with silicon, these form holes in the lattice. So as we can see that upon mixing the boron with silicon, the acceptor impurity creates a hole. So there is a hole formation here. The absence of an electron, as we said earlier, that what is a hole? A hole is an absence of an electron. So The absence of an electron creates the effect of a positive charge. Hence the type p type. Okay, so this is an easy way to remember for you all that in a p type semiconductor it is a P for positive. And what does positive mean? Oh, a hole. Hole is a positive. We can say a hole is a positive charge, right? Because it is an absence of electron. And so the holes can conduct current, and hole happily accepts an electron from a neighbor, moving the hole over a space. So this can be said that what happens here? We can say that when an electric field is applied, the hole can conduct current. So next we have the n-type semiconductor. In n-type doping, phosphorus or arsenic is added to the silicon in small quantities. So in n-type doping, we use phosphorus or arsenic as our dopants or our impurities. Phosphorus and arsenic each have 5 electrons in their outer shell, so they are out of place when they get into the silicon lattice. So when the phosphorus or arsenic is added to the silicon, we can see that there is an extra electron which is out of place. So this donor impurity contributes to free electrons. So this extra electron becomes a free electron. The fifth electron has nothing to bond to, so it's a free to move around. So this free electron can, what can it do? A free, so in metals we know that metals are ions in a sea of free electrons. So the free electrons conduct electricity, right? So here also in n-type semiconductors, this free electron is the thing that conducts electricity. So it takes only a very small quantity of the impurity to create enough free electrons to allow an electric current to flow through the silicon. What does this mean? This means that if we add only a small quantity of this impurity, this will create enough free electrons, and this can cause the electric current to flow when we apply an electric field. So electrons have a negative charge, hence the name p-type, n-type, sorry, my bad. So what does this mean? This means that this is another easy way to remember. N-type semiconductor is negative. So there is an abundance of electrons. So N-type semiconductor. So that was all from my side. Thank you everyone. I hope you enjoyed this presentation.